So this is where we left off for part one of our lecture for chapter two. We had covered specialization and specifically discussed why does specialization occur. Again, specialization will occur simply because there will be more goods and services produced overall than if there is no specialization. So think about it. What we're basically saying is a country can have a production possibility curve that looks like this, and we know the maximum amount of output that we can produce would be at any point along this curve. However, if we specialize and only produce one type of good and then trade with other countries for the goods that they specialize in, what we're saying is that we can attain a point of consumption outside of our production possibility curve. So that is why specialization is going to occur, because more goods and services will be produced overall. We can actually have levels of goods and services that are outside of our production capabilities. So that would be the incentive to specializing and trading. So again, just to reinforce this fact, the reason why we're going to trade and specialize is because, in theory, by specializing in the activities where our opportunity costs are lowest, countries or individuals will end up with more than if each tried to produce everything themselves. And again, if there are no gains from trade, then the trade will not occur. So this is key right here, the gains from trade. Again, going back to a production possibility curve, if there was no gains from trade, that would mean after trading with somebody else, we ended up with the amount of goods that were along our production possibility curve, meaning that we didn't actually gain anything. We ended up with the same amount that we could actually produce all by ourselves. And that wouldn't make any sense. Why would you go through the trouble of trading with someone if you're just going to end up with an amount that is equivalent to what you can produce all by yourself? So that's why we say the only way a trade is going to occur is if there are gains from it. In other words, both parties have to gain and end up with a point of production outside of their production possibility curve in order to engage in a trade agreement. So let's look at an example when we're talking about two individuals that are thinking about trading homework problems with each other. So let's say we have two students. Hypothetically, we have Elena and Josh, and you see that I have their production capability in this schedule right here. In other words, we're assuming that Josh and Elena are both taking a math course, and they're both taking an econ course, and they both have homework that they have to complete at night. And so looking at this schedule, we can see each of their individual production capabilities. So for Elena, we see if she devotes all of her time to economics, she can produce 10 econ problems at night, opposed to if she spends all her time doing math problems, she's going to be able to do 10 math problems. So that's where there's complete specialization. She's either just devoting all her time to doing econ homework or all her time to doing math homework. And then we see what happens if there's no specialization. If there's no specialization, she'll devote equal time to both math and econ, and she ends up being able to do 5 problems of each. And then we can look at Josh's information. For Josh, if he devotes all his time to doing econ, he's going to be able to complete 5 econ problems. Whereas if he completely specializes in math homework at night, he's going to be able to do 10 math problems. And if he devotes his time equally to math homework and econ homework, he's going to be able to complete 5 math problems and 2.5 econ problems. So from this data, we can look and see the total amount of homework problems that would be completed if there was no specialization. In other words, each student is just going to do all of their homework all by themselves. So if there's no specialization, again, we can look and see what Elena's production would be. Based on no specialization, Elena would end up doing 5 math problems and 5 econ problems. So she would do a total of 10 problems. And for Josh, if there was no specialization and he just did both, class assignments, he would end up doing 5 math problems and he would end up doing 2.5 econ problems. So he would end up producing 7.5 problems total. So Elena does 10 problems, Josh does 7.5 problems. So at the end of the day, the total amount of problems that get completed is 17.5 problems, right? So that's our output. In other words, that's the total amount of problems that will get turned in the next day for credit from their instructors. And so, of course, what we want to see is, can there be gains from trade here? What if Elena just completely specialized in one subject and Josh just completely specialized in the other subject, and then they traded problems with each other? Would they be able to turn in more problems overall the next day? In other words, would there be gains? Would there be more than 17 and a half problems turned in the next day if there was specialization? So what we have to figure out is who is relatively better at econ versus math. So we're not, it's easy to say, well, Elena, she's good at math and econ, but we're not looking at who has like the absolute advantage in production. We're looking to see is who gives up less in order to produce that particular good. What we call that in economics is a comparative advantage. A comparative advantage is the ability of one person or nation or business to do something at a lower opportunity cost than another. So remember, in the previous lecture, we just defined what opportunity costs are. They're what you have to give up when a choice is made. So again, looking here, we see that we can look at the opportunity costs involved for both Josh and Elena, right? Every time Elena does 10 econ problems, she's giving up 10 math problems, right? And every time Josh does 5 econ problems, he's giving up 10 math problems. So we can see the opportunity costs involved in their choices by analyzing the data here on this schedule, right? Each one has an opportunity cost. Depending on whether they devote their time to doing one subject or another, they're giving up production for the other subject. So what we want to look at again is the comparative advantage. Who gives up less? If one party gives up less than the other to complete the same exact task or production, then what that means is that they have the comparative advantage and they can possibly benefit by specializing and trading with each other. So that's what we're really looking for, is does Josh or Elena have the comparative advantage in either math or econ production? So what I want to do is actually draw the production possibility curves for both Josh and Elena so that we can see what they would look like. Now, when we're talking about drawing a production possibility curve for an individual, remember that we're not talking about multiple resources. Remember when we looked at our examples in the previous lecture for production possibility curves, we were talking about a nation as a whole that has multiple specialized resources. In this case, when we're drawing a production possibility curve for an individual, they are the resource. It's just one resource. So there's no specialized resources getting transferred. Therefore, there's not going to be a bowed out shape to our production possibility curves. They're just going to be a straight line. So again, based on the previous information, again, if we look back here, we can take this information that's in this schedule and put it on the graphs to draw Elena and Josh's production possibility curves. So again, I'm taking the data that's from this table in order to draw their production possibility curves here. So I have to have each axis. So again, we'll put econ on this axis, and we'll put math down here on this axis. And we know, according to that table, Elena, if she devotes all her time to econ, she can do 10 econ problems, or if she devotes all her time to math, she can do 10 math problems. So all we would do is connect the dots like so, and that is Elena's production possibility curve. And then we also know that it stated if there's no specialization and she does devotes half her time to econ and half her time to math, she's going to end up doing 5 econ problems and 5 math problems. So she would be right here along her production possibility curve. So this is her point of consumption, or again, her point of production, without any specialization. She's right there along her production possibility curve. Now we know Josh, according to that schedule, if he devotes all his time to econ, he can only do 5 problems. and if he devotes all his time to math, he can do 10 math problems. So his production possibility curve is going to look like this, and then of course, according to the schedule, if he just devotes half his time to econ and half his time to math, he's going to do 2.5 econ problems and 5 math problems. So he would be right here along his production possibility curve. So again, we can see that there's 17.5 total problems produced when there's no specialization in trade. So again, the first thing we have to figure out before we can even think about trading with each other is, does a comparative advantage exist? Will these two benefit by specializing and trading with each other? So we have to calculate out the comparative advantage. All right, so again, we want to look at the same information that was in our table because that's what we're going to use to calculate comparative advantage. So let's say we want to look at econ first. All right, so what we'll look at is Elena's data. So for Elena, we see that every time Elena does 10 econ problems, she gives up 10 math problems, right? That's her opportunity cost. That's what she's giving up every time she does 10 econ problems. But we want to know, what does she give up when she just does one econ problem? Because then we can compare what Josh gives up when he does one econ problem, and we can see if their opportunity costs are different. So in order to do that, we just have to divide this 10 by itself, and that makes it 1. So now we know for every one econ problem she does, and we do the same thing, divide this side by 10, and then of course 10 divided by 10, that becomes 1. Now we know Elena's opportunity cost for one econ problem. For one econ problem, her opportunity cost is one math problem. In other words, every time she does one econ, she has to give up one math problem. So that is Elena's opportunity cost for econ. Now we want to do the same thing for Josh, right? Looking at the data for Josh, we see that for every 5 econ problems he does, he gives up 10 math problems. But again, we want to see, what does he give up when he does one econ problem. So we have to divide this side by itself. 5 divided by 5 now becomes 1. And if we divide that side by 5, we have to then divide this side by 5. So 10 divided by 5 is 2. So now we see Josh's opportunity cost. For every one econ problem he does, he gives up 2 math problems. So now we can compare apples to apples. For every one econ problem Elena does, she gives up 1 math problem. For every one econ problem Josh does, he gives up 2 math problems. So what we want to ask ourselves is, who gives up less, right? The person that gives up less has the comparative advantage. In other words, they can produce the good at a lower opportunity cost than the other. So in this case, we can clearly see it's Elena. She only gives up 1 math problem of production, whereas Josh has to give up 2. Therefore, Elena has the comparative advantage. So if they were to specialize, Elena should be the one to produce the econ problems because she has the comparative advantage. Now we can do the same thing to see comparative advantage for math production. We're going to go through the same exact process. So again, we can look at Elena's data. We know for every 10 math problems Elena does, she gives up 10 econ problems. Again, that is her opportunity cost. And then we divide it by 10 because we want to compare apples to apples. So now we know for every 1 math problem she does, she gives up 1 econ problem. So again, this is Elena's comparative advantage for math, or her opportunity cost for math. For every 1 math problem she does, she gives up 1 econ problem. Now we do the same thing for Josh. We see that for Josh, based on our data in the table, for every 10 math problems he does, he gives up 5 econ problems. So we wanted to compare apples to apples, so we divide this side by 10, which means we have to divide this side by 10. And so 10 divided by 10 over here, so now we know for every 1 math problem he does, he gives up, 5 divided by 10 is 1/2. He gives up 1/2 of an econ problem. So when we're looking at math, Elena's opportunity cost for one math problem is one econ problem, and Josh's opportunity cost for one math problem is half of an econ problem. So clearly we see Josh gives up less, so Josh is the one that has the comparative advantage because he gives up less. So now we can see that Elena clearly has the comparative advantage in econ. Josh clearly has the comparative advantage in math. So because we've established the comparative advantage for both, we know that it's possible that these two individuals can gain from trade. So if we go back to our original graphs that we drew, what we're saying is that because Elena specializes or has the comparative advantage in econ, she will only produce econ, which means she will do no math production and she will only do econ. And we can see according to her production possibility curve, if she only specializes in econ, she's going to end up doing 10 econ problems. So that's going to be her total production is 10 econ problems. If Josh completely specializes in math, he's going to do no econ problems and he's going to end up doing 10 math problems. So that ends up being his total production. So we see the total amount of problems that get done, 10 econ plus 10 math, there's a total of 20 problems that are now completed when there's specialization. And again, recall how many problems were done when there was no specialization. Well, going back to that data that we worked out, we saw that there was only 17 and a half problems produced when there was no specialization. Remember right here, when there was no specialization, a total of 17 and a half problems were going to be produced. However, if there's specialization, 20 problems are going to be produced, which means there's going to be 2.5 extra problems produced because there was specialization. Now we get into the tricky part. How are we going to divvy up those 2.5 extra problems? In other words, both parties have to gain. They both have to end up with more than what they would have if there was no specialization in trade. So this is where the trade negotiations come into play. How are we going to end up trading so that both parties end up with more problems than what they would have had there been no specialization to begin with? So what I've done here is come up with a couple of trade ratios to see how both parties would end up based on the trade ratio they chose. Let's say the first trade ratio that was proposed was 1-to-1. Most students usually, when I say, okay, how should these two individuals trade? They usually say, well, let's do what's fair, 1-to-1. So if they traded a 1-to-1 ratio, what we're basically saying is that, for every one math problem that Elena gives Josh, Josh gives Elena every one econ problem Elena gives Josh, Josh gives Elena one math problem. So at the end of the day, we can see that they both end up with 5 of each problem, right? So again, most students usually think, well, that's fair. They both did 10 problems, they trade 1-to-1, they both end up with 5 and 5. However, look down here. I've highlighted the information for the levels of output or production that they each produce when there was no specialization. In other words, the point they were at along their production possibility curve. Notice that Elena, if she doesn't trade, she ends up producing 5 math problems and 5 econ problems. So Elena would not agree to this trade ratio simply because she can already produce that all by herself. She would have no gains from trade if she traded on a 1-to-1 ratio. In other words, Josh would be the one to gain all the additional problems. Elena still has 10 problems, which again, if we go back to the production possibility curve, that's what she had. She had 10 problems right here, 5 and 5. Whereas Josh initially before specialization trade only had 7.5 problems. So if we're looking at this new information, Josh ends up with 10 problems opposed to 7.5. So Josh is the only one gaining. He's getting the entire extra 2.5 problems of production. So again, we can just cross this trade agreement out right away because we know Elena is not going to agree to that. Let's say that Elena proposes the trade ratio 2-to-1 instead. So she says, for every 2 math problems you do, Josh, I will give you 1 econ problem. So at the end of the day, after they're done trading, Elena ends up with 5 math problems and she keeps 7.5 econ problems, whereas Josh, he ends up with 5 math problems and only 2.5 econ problems. So again, you can look at this trade ratio going either way. It's 2-to-1 for Elena or 1-to-2 for Josh, right? In other words, he's only gaining 1/2 of an econ problem for every 1 math problem he's giving Elena. Well, again, Elena ends up better off, right? In other words, with no specialization in trade, we can see she is at 5 and 5, but at this trade agreement, she ends up with 5 math problems and 7.5 econ problems. So in this trade ratio, Elena is gaining the entire 2.5 extra problems, and yet when we look over here for Josh, he ends up with the same amount that he would have had with no specialization in trade. So in this case, Josh would be the one to reject this trade proposal, right? So we can cross this one out because Josh didn't have any gains from trade. If you look at the very first trade ratio I have proposed here, this is a 5-to-3. So, for the 5, so Josh will give Elena 5 math problems, and in return, Elena will give Josh 3 econ problems. And so in this case, we see both parties are actually gaining from trade. With no specialization in trade, Elena had 5 and 5. Now she's going to end up with 5 and 7. So she gained 2 problems, right? So she had a gain from trade. Pen's not working too well there. And then Josh, before specialization in trade, he had 5 math problems and 2.5 econ problems. Now he has 5 math problems and 3 econ problems. So he gains 1/2 of a problem. So both parties gained. Elena gained 2 problems, Josh gained 1/2 a problem. Both of them end up with more than what they would have if there was no specialization and trade. So again, let's go back and look at those production possibility curves again to see how they are now able to attain a level of output that is more than what they would be able to attain if they were trying to produce everything themselves. So again, Elena's original production possibility curve was 10 and 10. And if she was doing it all herself, she would have been at 5 and 5. But now she's going to end up with, and then we have econ over here, math over here. And so again, if we look back here, she's going to end up with 5 math problems and 2 econ, or what does it say? 5 math problems and 7 econ problems. So now she's up here at 7 and 5. So Elena's right here. She's better off than what she would be if she was trying to produce everything herself. She's had gains from trade. We do the same thing for Josh. We have econ on this axis, math on this axis, and his production possibility curve looks something like this, 10 and 5. And then, of course, he was at 2.5 here and 5 here with no specialization. And at the end of the day, he ends up with 5 math problems and 3 econ problems. So he is right here. So both parties had gains from trade. Again, Elena gained 2 problems. Josh gained 1/2 of a problem. Now, the next thing that most students are going to notice or comment on is, wait a minute, Elena ended up with way more than Josh. In other words, she got 4 times as much of a gain than Josh did because she got 2 whole problems. Josh only got 1/2 of a problem. And this is where I like to emphasize the fact that free trade is not fair trade. Nobody said that free trade was fair. All we know is that if people or countries specialize according to comparative advantage and then trade with one another, that more goods and services will get produced overall. And again, that's exactly what we see. We went from producing 17.5 problems to producing 20 problems. So more output overall was produced when these 2 parties decided to specialize. Now, when it comes to how they divvy up the additional output, we can't always assume there's going to be equal distribution. And again, if you go back and look, well, what if we try to make it fair, a trade ratio of 1-to-1? That is where we immediately notice that that wouldn't take place. Elena would never agree to that simply because she would have no gains from trade. So again, Just because there's free trade and more output produced overall in the world does not mean that it's completely fair, that all countries and all individuals equally benefit from the trade. But again, what we can say is that everybody involved in the trade is better off than what they would be if there was no trade. In other words, if Josh decided he didn't want to agree to this trade agreement and say, never mind, Elena, I don't want to enter into this trade agreement with you, I'm just going to do all my math and econ homework by myself. Well, now he's here. The next day, instead of having 8 problems total to turn in, he's only going to have 7.5 problems to turn in, which means he's worse off than what he would be if he would have just agreed to the trade with Elena. So again, we're not saying that the benefits are equal. We're just saying that you cannot deny that both parties are better off. They have more output when they specialize in trade than what they would be without specialization and trade. Now, another thing that I want to emphasize when we're talking about countries specializing and trading with each other is that there have to be enforceable personal property rights. And it's something that we kind of don't often think about because we just take it for granted living here in the United States, right? In other words, we have infrastructure in place that enforces our individual personal property rights. So in other words, if I decide that I want to plant apple trees on my property and then grow those, trees and then sell them at the farmer's market, I have enforceable property rights that allows me to do that. Somebody can't just come onto my property and take away my trees or take the apples for themselves to sell, because I can call the cops to enforce my property rights of my personal property. You have to remember that around the world, not all countries have these enforceable personal property rights. And again, that's key here, is do you have infrastructure in place that enforces your personal property rights, right? And if you do, then you're going to be able to, make your property more valuable and sell it and engage in trade. If a country doesn't have that, then even if they are rich in natural resources and have the ability to produce valuable goods that can be traded, they don't have an incentive to do that because there's no guarantee that they will be able to maintain the goods for themselves. So think about if I'm a farmer in a country that does not have enforceable personal property rights and I plant an orchard on my land in order to grow the fruit and then sell it, in trade. If nobody will enforce my personal property rights, then that means anybody can come and take my valuable, fruit that I've planted and grown and sell it for themselves or just confiscate my property altogether. So that is why we want to remember that the reason why a lot of countries in the world have a very low profile in trade is not because they don't have rich natural resources that could be, valuable in trade. It's simply because they don't have infrastructure in place that enforces personal property rights. So nobody has an incentive to try to engage in trade. Another thing that I want to talk about quickly before I wrap it up is just some of the factors that influence comparative advantage. So I just walked you through mathematically how we can calculate comparative advantage, but if we're looking at the real world and countries that trade with each other, what are the factors that actually influence the comparative advantage? Why do some countries have lower opportunity costs than others when it comes to producing particular goods and services? And so part of the reason why particular countries have comparative advantage just comes straight to the fact that they have productivity differences. The human skill set may be different from country to country. So you have some countries that, can employ humans at a lower cost than other countries, which allows them to maintain a comparative advantage in the production of goods that require like physical human manpower. So think about the cost of a manufacturing worker in the United States compared to the cost of a manufacturing worker in China. Because you can employ humans for such a lower pay rate in China, it makes sense that they're going to have the comparative advantage. And then another thing we want to look at, like what I have here, is factor abundance. In other words, what actual natural resources does a country maintain? Because that will obviously influence whether or not they have a comparative advantage in the production of goods that require that as an input. So obviously a country that is rich in something like oil is probably going to have the comparative advantage in oil production because they have an abundance of that resource. So just the type of resources that a country has is going to influence whether or not they have the comparative advantage in the production of one good over another. Another thing we want to remember is that comparative advantages can also be manipulated. In other words, on paper, when we calculate comparative advantage, we can see, okay, it's very easy to determine this country can produce a good at a lower opportunity cost than this country, therefore they have the comparative advantage. But what happens if a country wants to protect their domestic producers? So in other words, let's say we're talking about the U.S., and let's say in the U.S., a sugar farmer, it costs them 25 cents per pound to produce sugar. And let's say we're talking about a country like Bolivia. So in Bolivia, let's say they can produce sugar too, and they can produce sugar, whoops, I did an O there. They can produce sugar at 10 cents per pound. So clearly we see that Bolivia can produce sugar at a lower cost than the United States, therefore they would have the comparative advantage. But what happens if the government comes in the United States and subsidizes the sugar farmers and says that we are going to give you, 20 cents per pound of production? That essentially lowers the cost of the U.S. sugar farmer. It's 25 cents a pound, but if the government's going to cover 20 cents of that, they're going to subsidize the industry 20 cents per pound. That means a U.S. sugar farmer, you would take the 25-cent actual cost, subtract the value of the subsidy, and they can actually then effectively produce their sugar for 5 cents a pound to break even. So now it looks like the U.S. has the comparative advantage because they can produce the sugar at 5 cents a pound because of the subsidy that the government is giving them. So I do want to emphasize that fact that in the real world, it is very, very common for the industrialized nations to manipulate comparative advantage to their benefit to protect their domestic producers. So again, you can have countries that actually have the comparative advantage, but once governments step in and start giving subsidies or quotas, which basically means restricting the import, the number of imports that can come from around the world, imposing taxes or what we call tariffs on imported goods, it completely manipulates the true comparative advantage. So that is truly just a real fact about what goes on when it comes to international trade, that it's very, very heavily influenced by the policies in place by the country, the countries that are trading. All right, and then the last thing I want to emphasize is also the fact that comparative advantage is not set in stone, right? In other words, one country can start out having the comparative advantage and then they can lose that comparative advantage. So you'll notice here the last bullet point that I have would be product life cycle. So think of something like the color television. The color television was created, invented, and initially produced and manufactured in the United States, right? So we had the comparative advantage in the production of the television. However, what happened over time? Other countries can effectively copycat that technology and then start producing it in their countries at a lower cost. So that's exactly what happened, which is why most televisions are no longer produced in the US, because other countries have been able to effectively, again, copycat it and then produce it at a lower cost. So then the comparative advantage shifts to those countries that now have the ability to produce it at a lower opportunity cost than the United States. So again, all three of these factors, that are these 3 bullet points, I should say, are huge factors in determining, or influencing who has comparative advantage in the production of different goods and services around the world. Okay, so to wrap up chapter 2, again, the things that you really wanted to make sure that you, completely understand after reading chapter 2 is you want to make sure you understand opportunity costs, what they are, and how you calculate them. You want to understand how opportunity costs relate to specialization, right? In other words, the fact that if someone can do something at a lower opportunity cost than somebody else, then there may be benefits from trade. So of course you need to be able to mathematically calculate out opportunity costs in order to figure out if there can be those benefits or gains from trade through specialization. You also want to know that when someone can do something at a lower opportunity cost than somebody else, we refer to that as having the comparative advantage. And again, whoever has the comparative advantage in the production of a good, that means that you would completely specialize in the production of that good in order to have those benefits or gains from trade. We also want to make sure we understand that in order for all of this to take place, there have to be enforceable personal property rights. Nobody can engage in trade and benefit from it if they don't have enforceable personal property rights. And then, of course, lastly, you want to make sure you understand what those factors are that influence comparative advantage. In other words, factor abundance, human skills, government intervention in terms of tariffs, quotas, and subsidies, things like that. But if you can understand all of this after reading chapter 2, again, understand what opportunity costs are, how you calculate them, how they relate to specialization, if you can understand how to mathematically calculate comparative advantage and then determine, benefits from trade, you're going to be able to successfully complete the problem set and the quiz for chapter 2.